laws of exponents today. So what we're going to go through is we're going to go through each rule and we're going to look at it mathematically, put in some writing what it means, and make sure that we understand that rule applies each time that's going to happen. So if we look at the first rule, product of powers, what's happening is you're going to have the same base. So you have a to the m times a to the n. And if you notice, you keep the base the same, but you add your exponent. So you keep the base the same and you add the exponent. So let's go ahead and just kind of break that down, what that means. Base is the same. When you multiply the same base, you will add the exponents. When you multiply the same base, you will add the exponents. So if you notice over here, we have x squared times x to the fifth. That means you are going to keep the base the same and you are going to add the exponents. So that would give us x to the seventh power. That would give us x to the seventh power as our answer. For quotient of powers, that's going to be division. So product, you're thinking multiply. Quotient, you're thinking division. Maybe let's write that down just in case we need to. Multiply, and then quotient, we're thinking divide. And with quotient of powers, you have a to the m over a to the n. So notice, same base. And you are going to subtract them. So you do the top minus the bottom. When dividing bases that are the same, subtract the exponents. You're going to subtract the exponents. So right over here we have x to the eighth power over x to the sixth power. Keep the base the same, subtract the exponents. So I took top minus bottom. That's going to give us x squared. Next up, we're going to have power of a power. So if you notice, this is different than multiplication because you have a base that has an exponent raised to an exponent. So do not get that confused with the multiplication. You have an exponent raised to an exponent. And if you notice over here, they just write the m and the n next to each other, which means you're going to multiply them together. So an exponent raised to an exponent see how I want to say that, sorry. Multiply powers. Okay, I'm not sure that's the best way to say that, but if you have an exponent raised to an exponent, if there is, that sounds a little better. If there is an exponent raised to an exponent, you're going to multiply the powers. So right over here, you have x squared raised to the fourth power. So you would have x 2 times 4, x to the eighth power. So if there is an exponent raised to an exponent, just multiply those powers out. A negative exponent. Anytime there's a negative exponent, you're going to have to move it to the other part of what would be the fraction. So this shows you right here, you have a to the negative n. So you're just going to put 1 over a, and then the exponent changes to positive. So to change to a positive, move to bottom of fraction, or top if you need to, because sometimes they are in the bottom and you have to move it to the top. So right here, if you have x to the negative 3, we all know that if it's just a whole number, x to the negative 3, that's kind of like saying x to the negative 3 over 1. So basically, you are bringing this down to the bottom of the fraction. So that's going to be, and if you bring that down, there will be just 1 left on top over x to the 3rd power. So I just brought it to the bottom of the fraction, changed the power to a positive. For the 0 power, anything raised to the 0 power is 1. Raised to the 0 power equals 1, no matter what. So this is x to the 0 power, it equals 1. Anytime you have something raised to the 0 power, it will equal 1. Let's do a couple examples. We're going to use the appropriate laws of exponents to simplify each of the following. So on this first one, let's kind of break it apart. I would go ahead and I would look at the fact that you have coefficients. You have coefficients that you can get multiplied together. We see that multiplication sign here in the middle. 4 times 8 would give us 32. And then you have a to the 4th power times a to the 3rd power. A to the 4th power times a to the 3rd power. You also have b to the 6th power times b to the negative 2nd power. So b to the 6th power times b to the negative 2nd power. You're going to have to add those together. So you would have a to the 4 plus 3 power. And then for the b's, you have b to the 6 plus a negative 2 power. So let's just remember what we need to do there. 4 plus 3 is 7, so that would give us a to the 7th power. 6 plus a negative, that's going to be 6 minus. 6 minus 2 is 4, so that will be b to the 4th power. And then that would be your answer for that example number 1. So break it down. Let's look at example number 3. Looking at example number 3. With example number 3, same concept. You're going to break it down. I would look at coefficients, then I would look at a's, then I would look at b's, and then I would look at c's. So the coefficients, that can be reduced because they're both even numbers, and even more so than even, 4 can go into both of those. So negative 8 divided by 4 is negative 2. 12 divided by 4 is 3. Now here's what we need to think about. We reduce the coefficients, and now, like I said, we're going to be kind of breaking apart the a's, and then the b's, and then the c's. So I'm just going to write it out to the side again. I'm going to have a to the 10th power minus 7. Why did I subtract it? Because it's being divided. And we know, based on the quotient of powers, you subtract the exponents when the bases are being divided. Next, do the same thing with b's. 14 minus 6. And then the c's, 3 minus, if there's no power there, you're going to assume it's 1. Okay, so I'm just going to move this down a little bit so that I don't run into anything. But I'm going to have my negative 2/3 that I have, and then I'm just going to write my variables behind it. So 10 minus 7, that will be a to the 3rd power. 14 minus 6, that will be b to the 8th power. 3 minus 1, that would be c squared. So your answer for this, once you reduce it down, would be negative 2/3 a to the 3rd power, b to the 8th power, c squared. Okay, example number 4, last but not least, this one's definitely kind of meaty. What you need to do is, if you notice this parentheses, you're going to think of that distributive property anyway. So what you're going to do is you're going to square everything inside the parentheses. But right now, if you think about squaring negative 24, that's going to get out of hand real quick. So if you have something like this and you can break it down a little bit before you square it, that would be my suggestion. So let's go ahead and let's break it down before we square it. Do not forget to square it at the end. Okay, so I'm just going to keep it in parentheses so I remember to square it at the end. And then if we set it up, we have negative 24 over 8. So let's deal with that first. Negative 24 over 8. Negative 24 can be divided by 8, and that gives us 3. So I'm going to put negative 3 on top, and I'm going to go ahead, I'm going to put 1 on the bottom. Because I know that 8 has gone into negative 24 3 times, and 8 goes into 8 1 time. Next up, I have my x's. So if you notice right here, that's a negative. So if I bring it to the top, that's going to become a positive 4. So I have x to the 16th power plus 4. That gives me x to the 20th. I have y's. Now my y's are going to be the traditional quotient of powers rule because they're both positive. So I have y to the 5th power and I have y to the 3rd power. So I'm going to do y 5 minus 3. That's going to give me y squared. And then z to the 0 power, that's just 1. That's just 1. So now if you're looking at your denominator, you have 1 times 1, which is 1. So really, this is just going to be negative 3x to the 20th power y squared. And then just like I said before, I almost forgot it, but I didn't. You're going to square that whole thing. So I'm going to put that parentheses back there, and I'm going to square the entire thing. So I'm going to take negative 3, and I'm going to square it. Negative 3 squared. And then I have x to the 20th squared. And then I'm going to have y squared. Negative 3 squared gives us a positive 9. This is going to be power of a power. So I have 20 raised to the 2nd power. 20 times 2 is 40. 2 squared is 4. So I have 9x to the 40th, y to the 4th.